Parallel and perpendicular lines. Parallel and perpendicular lines. Tell me what you know about parallel and perpendicular lines. Do you know anything? Parallel lines never intersect. You're exactly right. They never intersect. They go on forever and ever, and they never intersect. They look something like this, but we're not going to assume lines are parallel without justifying algebraically, and we'll get to that. But we do know that parallel lines never intersect. Tell me about perpendicular lines. They cross or intersect. What's special about where they cross or how they cross or intersect? They intersect at a 90-degree angle. Okay, perpendicular means they intersect at 90 degrees. Okay. All right, so what we're going to do is we're going to look at lines that are parallel and perpendicular, but algebraically look at these lines. And what I mean by that is we're not going to actually graph them and look at them. We're going to look at their equations and tell if they're parallel or perpendicular. Does anybody know how we can do that? We're not going to look at graphs at all. We're going to completely ignore this. We're going to completely ignore this. We're going to just look at their equations. What about the slope? You're actually right. Parallel lines, you're exactly right. Parallel lines always, let me go to a new slide. Parallel lines always have the same slope. That's what keeps them from intersecting, right? If you think about it, if I had this line that from this point I went up 1 over 1 every time, up 1 over 1, right? If I had another line that starts over here and every time I go up 1 over 1, up 1 over 1, these lines are never going to touch, okay? They start at different places, but they never touch. Why? Because their slopes are the same, okay? So parallel lines have the same slope. M is slope, that's right. They're slid over. They start at different places, but the slopes are the same, so they'll never intersect. I'm going to show you. I'll show you what to do. Right now, I just want you to understand that parallel lines means same slope. Okay? Perpendicular is where they cross. Okay? So you got to think they're completely opposite on their slope. Okay? They have what we call negative reciprocal slopes. Okay? Which means, now even though it says negative, what I really mean is opposite sign. So if it starts out negative, it ends up positive. If it starts out positive, it ends up negative. Okay, so what I like to tell students is opposite. And what does reciprocal mean? Negative reciprocal slopes. What does it mean to be a reciprocal? Remember y'all talked about reciprocate? What's that mean? Flip it. So opposite flip for the slopes here, okay? Let me show you, let's talk about a couple examples, because really, if you remember about the slopes, then everything else really follows. First off, let me give you two equations. Or actually, let me do this. Let's say, I'll give you two equations. Y equals 2x plus 3, and y equals 2x minus 5. Are those two lines parallel or perpendicular or neither? Why? What's the slope? What's the slope of this one? 2. Don't keep the x with it. What's the slope of this one? 2. The slopes are exactly the same. Do you agree? That means the lines are parallel. Okay? Right now we're just looking. Tell me this. I have a line like this. What is the slope of the line perpendicular to this one? By the way, I'll use this symbol for perpendicular a lot. If you see that, that means perpendicular. Okay. This means perpendicular. This means perpendicular. This means parallel. It's just a geometry shorthand that we use. So my question is, what is the slope of the line that's perpendicular to y equals negative? Y equals 2/3 x plus 3. Negative what? Close. Negative, change the sign, flip the fraction. Okay? You don't get it? Okay, what is the slope of the original line? If you flip and change, opposite flip, it would be positive. Opposite flip. Okay, so let me show you one like that. What if, that's a great question. Let's say the equation was negative 3x plus 1. And I said, what's the slope of the line perpendicular to that one? So, all right. So the question is, what's the slope of the line perpendicular to this? All right, let's look first. Wait, and don't keep the X on it. Okay, so, but look, first of all, what's the slope of this line? No. Negative. You're getting so excited, you're just shouting numbers. Okay, negative 3. Now, if I want the perpendicular slope, what do I do? There's two things I have to do. Opposite flip. How do you flip a whole? Yes. Any whole number is over 1. So, I apologize, Christian. I'm sorry. All right, look. I changed the sign. I flipped the slope, okay? Because it's over 1, any whole number is over 1, right? It's positive, right? So, if it starts out negative, it ends up positive. If it starts out positive, it ends up negative. You're supposed to do the opposite of... All right, if... Put it over 1, yes. Yes, yes, yes. Not always, it just depends. If I started out, Kennedy, let's say my equation was 1/2 x plus 3. The perpendicular slope would be negative 2 over 1, which is just negative 2. Yeah. You could. It's not wrong if you do it. I just wanted to show you how it's changing, how it's flipping. No. Okay, so we're using this information. We're going to use this information to write equations, okay? Watch what happens. Let's say, y'all ready for this? Let's say I want write the equation of the line. It's going to have two stipulations. It's going to be parallel to y equals 3x minus 1. Okay? So you have to keep straight what parallel and perpendicular means, right? It's going to be, that's okay, guys. All right. Parallel to this line, that's stipulation number 1. Stipulation number 2 is I want it to go through the point negative 3, 5. Okay? So, let's talk about what information we gather from what we're given. Okay? If I know the line is parallel to the first line, the equation, what does that tell me? Okay, remember we've been writing equations of lines, right? We've been writing equations of lines given 2 points, given a slope and a point, given a slope and an intercept. That's what we do with the sundown. All right, shh, shh, shh. Okay, before we even take another step, here we go. We're writing the equation of a line, and there's 2 things that's got to happen. It's got to be parallel to this, and it's got to go through this point. Okay? Tell me, if it's parallel to this line, tell me what that means as far as the equation. Same slope, right? Same slope. So now I know if it's the same slope, what does my slope have to be? 3. So now let's change the directions a little bit since we know that. Now, well, it's not perpendicular, it's parallel. Parallel is exactly the same. So now let's think about it. Let's write the equation of a line with a slope of 3 and through the point negative 3, 5. What is it? Because that's the information I gathered from that. All I needed, all those words in that equation, the only thing I needed from that was the slope. You're setting up in slope-intercept form. Is that what you're doing? Okay, so Zaya wants to do slope-intercept form, so she said this is going to be her x, this is going to be her y, this is going to be... I would do point slope. I'll do both of them and show you. I like point slope. That's my favorite form. But if you like mx plus b, that's fine. Cameron. Yep, yep. All right, 5 equals 3x. Not x. It's negative 3. Plus b. That's what you told me, right? All right. 3 times negative 3 is negative 9. And I solve it, right? Plus 9 on both sides. So you get 3 times negative 3. If you put in point slope form, I'm going to show you it's a lot less work. All right, so the equation of this line would be y equals 3x. Okay. Now, Ricky and Kennedy have asked about point slope form, and I would use point slope form also because I use unless it's specified, I use what I'm given and try to do the least amount of work because I'm lazy. Okay. So if I'm given a point and a slope, I'm going to use point slope form. If I'm given a slope and an intercept, I'm going to use slope intercept form. Okay. I look at what I'm given to determine what form I'm going to use. So if you use point slope, because you have a point and you have a slope, no. Y minus 5 which is y minus 5 equals 3 times x plus 3. Unless it tells you to put it in slope-intercept form, you can leave it just like this. I don't know why that crossed out like that. Which means, look at the work, look at all the work that you have to do in this form compared here. But if you understand it better and it's easier, that's fine. Okay? Or perpendicular. Okay? So let's do a perpendicular. Okay, tell me when you go. Let's say this time I want the equation of a line perpendicular to y equals 1/2 x plus 3 And through the point, come on, pen, through the point 5, negative 10. What in the world do I know? So this slope is 1/2, which means my new slope is going to be negative 2. Okay? And through this point, which means this is my x and this is my y. So if I use point slope form, Zaya steady writing in her slope intercept, right? You doing slope intercept? Okay. All right. Yeah. I'm going to do y plus 1, because it's y minus negative 1, equals slope. All right, so if you did point slope form, you're done. I agree. If you did slope intercept, and some of them, when I did your review and worked it out in the video, some of them I used point slope, some of them I used slope intercept, so you could kind of pick and choose which one you did when it wasn't specified. If you used mx plus b, then, yep, use the new slope, so you'd have y equals new slope times 5. Okay, so negative 2, yep, negative 10. So what is b? Positive 9. Ah! Oh my goodness, what is my computer doing? Uh-huh. Y equals, be nice, what's your m? Negative x. What's your b? Now, if you distributed that negative 2 through, you could get it back to this form. I tend to use point slope and manipulate it as I need it, regardless, because it's so easy to plug into. Let's see if you understand parallel and perpendicular. I'm going to give you several equations, and let's talk about them. All right, these are going to be a little bit harder because you're going to have to do a little bit of manipulation, guys. You're going to have to do a little bit of manipulation to determine the slope. But my question is to you, looking at these lines, are there any that are parallel and are there any that are perpendicular? Any parallel, any perpendicular. To determine, yes, to determine if they're parallel or perpendicular, I have to determine the slope, right? First one's easy peasy. We're not manipulating. Right now we're just looking at the equations. It's just 5. What is the slope of the second equation? Yes. You got to get y by itself. You got to subtract the x. I got to put it in slope-intercept form in order to find out the slope, okay? So somebody said you got to get rid of the x. Right? And then we must divide by 5. Well, you have to be able to look at them and see. We're just seeing if they're parallel. Now, if I ask you what is the slope of the line that is parallel or perpendicular, that's when you do that. But if I just ask you which of these lines are parallel and perpendicular, then you just need to know what the slope is. So here, there's an imaginary 1 in front of here, right? So I've got negative 1 over 5x plus 2 over 5. Remember that 5 goes to both. So what is the slope of line number 2? Negative 1 over 5. Okay? I've got a slope. Look at the last one. I need the slope. What do I do? You add 2x. That's exactly right. Now what? Negative 2 over 10x is the same thing as negative 1 over 5x. Do we agree? What is the slope of line number 3? Yes? Does that make sense? You're the student, it's your job to know. Okay? So, looking at these, are there any parallel lines in this set of 3 lines? The second one, all right, I'm going to call this equation 1, equation 2, and equation 3. You tell me 2 and 3 are parallel. Why? How about, are there any perpendicular lines? Look closely. 1 and 2, they are. Why, Cameron? They have opposite reciprocal slopes. You're absolutely right. 1 and 3 are also perpendicular because their slopes are also negative reciprocal. They've flipped and they've changed the sign. Does that make sense?